Hello. We're going to go over section 5.1, talking about monomials and properties of exponents. The section number got cut off on your notes, but it's for section 5.1. I'm not going to read through your notes just to save a little bit of time, so if you guys want to stop and look at your instructions at the top, that's fine. You can stop right now, or we'll just go ahead and start. I'll explain a few things as we go along. So, first of all, we need to go over what a monomial is. And a monomial could be just a number, like our product of numbers, like 25. That's considered a monomial, even though it doesn't have a variable. Okay, so you could also have something with variables, 3xy. That's considered a monomial. Okay, they're all being multiplied together. Now, some examples of what a monomial cannot be is if you have something like 2 over x. You cannot have a variable in the denominator. So these are all not monomials that I'm giving you examples of. Okay, you cannot have a variable with a negative exponent. And we'll go over what a negative exponent means in a minute, but you can't leave, that's not a monomial. You cannot have a variable inside a root. That would not be considered a monomial. Okay, so these top ones are monomials, and the bottom ones are not. And a monomial is just an array or an expression consisting of numbers and letters, or just numbers or just letters. Okay, so they're all being multiplied together. So x, y, z, all being multiplied together, that's a monomial. Okay, so each monomial has a degree, and the degree is found by adding the exponents on the variables. So for example, if I had x squared y z to the third, and they want me to say what the degree is, I'm going to add the exponents together. So 3 plus 1 plus 2 is going to be 6. So the degree of this monomial is 6. That's all that they're talking about. If you have just one variable raised to a power, then the degree for this monomial is 5. So it's just the exponent added together if it's more than one variable. A constant number, if you have like a 5x squared, that coefficient doesn't have a degree. So you wouldn't add a 1 or anything for that coefficient. It would just be 2. You don't count the coefficient. It's just the degrees on the variables. Okay, so to simplify expressions with exponents, you will follow the properties of exponents. And you can find that in your book on page 303 if you want to look at it in your book. It is on your notes here, and let's go over all of the different things. Okay, so you don't want to leave negative or 0 exponents in the answer. So to multiply powers with the same base, keep the base the same and add the exponents. So if you have powers with the same base, you're multiplying them together, you keep the base and add the exponents. You guys have done this since Algebra 1, so that should be very familiar. When you're dividing powers with the same base, keep the same base and subtract the exponents. So if I have x to the third divided by x squared, I'm going to take the top exponent minus the bottom exponent. Okay, so this would work out to be just x to the first power. I'm going to do another one, x to the 7th over x to the 3rd. So I would take the numerator exponent, subtract the denominator exponent, and this would be x to the 4th. So let me turn this sheet over here. To raise a power to a power, the base stays the same and you multiply the exponents together. So if I have a variable in parentheses like this and another exponent written right next to the parentheses, so they're right next to each other, you multiply those exponents together, 2 times 4, and that's your simplified monomial. To raise a product to a power, raise each factor to that power. So for example, if you have in parentheses x times y raised to the 3rd power, That means you're going to apply that exponent to each variable. So you would have x to the third, y to the third. To raise a quotient to a power, raise the numerator and the denominator to that power. So let's say you have y divided by z, and it's in parentheses, and it's raised to the fourth power. So you would raise the y to the fourth power and the z to the fourth power. Okay, let's say you have a coefficient 2x over y, and it's all raised to the second power. Then you would want to raise the 2 to the second power. That'd be 4. X to the second power, y to the second power. Same thing with your product. If you had a number in front, you would want to raise that to the third power as well. Okay, remember the rule that anything raised to the 0 power is 1. So if I have 10 to the 0 power, that's 1. You need to simplify that. Don't leave anything to the 0 power. If you have x to the 0 power, that's 1. Anything to the 0 power is 1. And negative exponent means you have a reciprocal. So let me show you an example of that. Let's say we have x to the negative 2. Okay, now this x right now is written as a whole number. It's over 1. What this negative means in the exponent is that the x needs to go on the other side of the fraction bar. So to simplify it, you would move the x to the denominator, and then the exponent is going to be positive. So anytime you have a negative exponent, you have to move the base to the other side of the fraction bar. For example, if I have 1 over y to the negative first power, okay, this y has a negative exponent. That means that the base, the y, needs to go into the numerator. And you don't have to write the first power or that it's over 1. Okay, you could just write it as y. That's the same. So let's do one more. Let's say I have 1 over z to the negative third power. That negative means I need to move the base, the z, to the other side of the fraction bar. So I'm going to put it over 1 just to show you. And once I move it to the other side, then the exponent becomes positive. So you could simplify it to z to the third. Okay, so let's move on and do some examples. Actually, why don't we take a little break right now, and then you guys can come back and we'll do some examples. Okay, we'll see you in a minute.